Debbie. All right, so this session is on engineering and coding through virtual smart model homes. Again, my name is Adria Fung. I teach at St. Louis School. If you folks have any questions or anything like that, you can feel free to email me down below. My email is listed there. And like Debbie said, this presentation will be available afterwards for your reference. All right, so let's get started. So a little bit about myself. I'm a middle school robotics teacher and coach at St. Louis School. So I teach primarily middle school robotics electives. And I'm also teaching one class of engineering one for high school. My background's in robotics engineering and curriculum studies in STEM. So specifically, I'm looking at creating curriculum for robotics classes and also tying it in with the various engineering disciplines to bring to life all of these amazing robotics projects that the students can do. Pretty much my vision, my goal is to really empower students with the opportunities and knowledge to take on global challenges using STEM and robotics. So as much as I love the competitive robotics, I did competitive robotics when I was in high school. I definitely love teaching the students that there's more to robotics than just competition and battle bots and all of that. Definitely taking a look and seeing what kinds of problems we have in our community and how we can really solve it with robotics and various engineering disciplines. All right, so whether it be robotics class, engineering class, the three disciplines that I like to go over with the students in the classes are mechanical engineering, electrical engineering, and also computer science. So in this case, for this workshop, we're going to be talking about pretty much the big project that the students will end up doing, which is the virtual smart homes. So for the virtual smart homes, that includes 3D modeling, also teaching them electronics and coding. So kind of take a look. Those are just some images or screenshots from the website that I'll be introducing to you guys. So it's just one website doing pretty much this for this entire project. So it encompasses CAD, coding, and also circuitry and electronics. Pretty cool website. All right, so like I said, pretty much my goal is really to help develop curriculum for robotics and also engineering. For this specific project, the virtual smart homes, I've created kind of a 3-unit model and also included individual lessons for each unit. So for the first unit, I introduced the students into 3D modeling or mechanical engineering. Some of the lessons that we cover are isometric drawings. So actually learning how to do isometric drawings on paper and looking at different blocks or actually using building blocks and building it out to do isometric drawings. The second thing would be orthographic drawings. And so orthographic drawings are pretty much top, front, and side views. So taking those 3D drawings and then looking at the top, the front, and side views and actually drawing it out on graph paper. The next lesson that we cover would be dimensioning. Pretty much learning how to use a ruler. There are a lot of students in my class that don't know how to read a ruler, so I think that's a valuable skill to have pretty much in this day, is learning how to measure and be able to dimension it on their orthographic drawings. So once we kind of cover those basic skills of drawings, 3D drawings, and also 2D drawings and dimensioning, then I introduce the students into actual 3D modeling on a computer. So using a website called Tinkercad. So we would do various lessons on it, some model projects, some sample lessons that they have provided on the website, which I'll show you guys later on, and doing things like that. And then kind of a culminating project that I would have them do is to model everyday objects. So modeling a cup or something from their kitchen, something from their bathroom. And then the culminating project would be designing your own pen holder. So that's something that my middle school students did this year. Really cool. Some of them designed really nice pen holders. And if you folks have the capabilities and have a 3D printer in your classroom, you can even 3D print it out for them. And so that's what I did. So one pen holder would take maybe like 7-8 hours. Some would take like 20 hours to print. But honestly, I think it's worth it for the kids to see that what they modeled on the computer can actually come and bring it to real life. So that's really cool for them. All right, so that was the 3D modeling unit. The second unit would be electronics and coding. So for those lessons, we would talk about identifying electronic components. So very simple electronic components. If you've worked with circuits and Arduino specifically before, you've probably seen things like breadboards, LEDs, sensors, jumper wires, batteries, things like that. So teaching the kids to just learn how to identify those basic electronic components first. We would do various Kahoot games, during our fast-paced Monday schedule. So kind of get them into thinking that, okay, recognizing that's an LED. All right, that's a breadboard. All right, those are batteries and those are jumper wires, things like that. And then I would go into actually doing an intro to Arduino. So Arduino is the platform that provides pretty much the brain or the board that you would use to download code into it and be able to wire it to your peripherals or your sensors or LEDs. So it's pretty much taking that code and bringing it to real life in a way. You can find Arduino kits on Amazon for pretty cheap, or you can assemble them on your own. And I'll give you guys later a list of items that I provided my kids with the Arduino. But of course, that's only if your school allows it, if you're an in-person school. If online, no problem. We can do Arduino on Tinkercad. So I'll show you guys that afterwards. Then I would go into Arduino tutorials with them. So going through various tutorials, actually modeling it out and simulating it on the website. And then slowly introduce the sensors, learning how different kinds of sensors work, like photoresistors, which is a light sensor, temperature sensor, and actually coding things like that. So basic projects like if a photoresistor determines that there is no light, you would have the LED turn on. Or if the photoresistor determines that there is light, the LED would be off. So that's kind of modeling what a low contact porch light would be like. So kind of breaking it down from what kids see every day in smart homes and breaking it down into very basic electronics. And then the culminating project for this unit that my students did, kind of for their final exam as well, was a traffic light project. So they actually had to model traffic lights for their project. I challenged them to do a no contact traffic light. So pretty much how would you signal a crosswalk signal to turn on by not pressing a button? So of course, in this day, I think it's very relevant. We want to make things very low to no contact technology. And so a lot of the students would choose ultrasonic sensors, which is kind of like a distance sensor, or some of them would have like a push button that's mounted on the ground. So it's only their feet that's pressing on it. And so that would signal for the crosswalk light to go on. Really cool project. And then lastly, of course, the final unit would be the virtual smart home project. So that's kind of like taking that big project that the students would submit and breaking it down into smaller goals or smaller projects in order to lead up to that final project. So of course, this teaches the kids very, how should I say this, critical skills of not just engineering and technical skills and knowledge, but also time management, planning, making sure you set goals, set deadlines. I challenge the students to create a weekly agenda for themselves. So what assignment are you going to submit to me by Friday? And you determine what you want to submit to me, whether it be a sketch, your research, and things like that. So that would include things like here, the planning, sensor integration, sketching out a floor plan for your home, of course, dimensioning and scaling your home so it's smaller on the model itself. Actually 3D modeling or Tinkercadding out the house, modeling the circuits that will go inside the house with all of the sensors involved. And then, of course, finally, I always make the students do a presentation, since I think that for engineering, it's definitely a valuable skill for the students to be able to present their ideas and convey their thoughts and design process with an audience. All right, so that's pretty much kind of the overall big picture of it. I think that these units can definitely be taught from upper middle school and definitely throughout high school. So I listed some NGSS standards that are followed with these lessons and units. All right, so moving on to the actual website itself. So kind of like the very secret weapon that saves me throughout this online teaching here. So Tinkercad is the website that I like to use for students to learn how to 3D model on a computer, or also doing Arduino circuits on here. All right, so like I tell my students, if you think that I'm going too fast, feel free to use your phone to take a picture of the screen. If you want to, you can also jot down notes. If you have any questions, feel free to type in the chat, and then we'll get back to you at the very end of the presentation. All right, so let's see here. Sorry. Okay. I'm gonna log out so that you guys can see. Let me log back in again. All right, so, oh no, Tinkercad is under maintenance. Oh my gosh. What are the chances of this happening? I had everything like all set up to here. Cannot believe of all the times right now, it has to be under maintenance. Yeah. Let's see. All right, so pretty much what you would technically see here would be something that would say join now. And so as an educator, you would click on the join now to sign up for an account. Your students don't need to sign up themselves. So when you actually go into the Tinkercad, you can actually create a class in there, which I really wish I screenshotted everything, but I did not expect that Tinkercad would actually be down for maintenance. But I mean, we'll keep trying, hopefully, but I cannot believe it of all the times. It's like, it's crazy. Oh my gosh. So Debbie's like, no, keep going, keep going. Yeah, so pretty much, hopefully you guys can still follow along as I am explaining this to you guys. We'll come back to the slide here. So when you go into Tinkercad, you can pretty much go in and set up your classes. So when you go and set up your classes, you would click on, I believe it's create a new class, and then you would then create an account for every single student that you have. So I created an account for all of my students, and you can organize them per class. So I would have one for, say, grade 6 robotics, and I'll have all my students in there. So you can even create their own usernames so that they don't have to remember it. There's also the best part, there's no password needed. So the students don't need to write down any passwords down or anything like that, or be like, oh, miss, I forgot my password to this. They just need their username, and then they just need to have your class code. So once you create the class on Tinkercad, you can then create the, then you can take the class code, similar to Google Classroom. You would take the class code that's for the Tinkercad class, and you can just paste it onto your class website, your Google Classroom, things like that. So the students would have to log in through the class website in order to log into their accounts. So once they do that, they type in their username, and then it takes them to their own specific accounts. So the best part of it is that when you set up these classes, the students are able to actually show you their work without you having to tell them, take a screenshot of it or send me, share with me a link. We all know how, humbug that is with Google Docs and all with sharing links. But on Tinkercad, it's very simple. You just click on the student's account and you can actually see their individual projects that they are working on. So when you tell them, okay, all right, your Tinkercad project is due by Friday, and then they just have to say that that's their project, and then definitely tell them rename their project so that you know exactly what you're grading as far as what you actually want to grade. So that's the best part of it. So definitely easy to track their progress and work from it. You can actually even look into their 3D models and also the circuits and the lessons as well to see if they completed any lessons. And then pretty much at this point of the presentation, I would show you guys on Tinkercad that I recommend that the students should start on the lessons first. Have them go through the starter lessons and the starter projects to get them familiarized with Tinkercad before they actually start building things on their own. And then then you can have them do different kinds of projects like building a house, modeling everyday objects, and also pretty much modeling whatever you want. Pen holder. I had my high school engineering students model contactless tools as well. So kind of like those, what is it? Those kind of like keys or low contact, no contact keys that you find on keychains to press buttons. I had my engineering students model those and 3D printed out those for them to take home. So pretty much those are kind of the capabilities of Tinkercad as far as the 3D modeling side. I listed here some resources that you folks can get started with that I actually use for that specific unit, the 3D modeling unit. So for example, like this one here, the Teach Engineering. These ones are great for the isometric and orthographic drawings. So I'm pretty sure, let's see, I have it right here. Okay, so this one is isometric drawings and coded plans. So you can take a look and see these are pretty much, Teach Engineering is a great platform for finding engineering curriculum, engineering activities, even sub-plans if you need any, it's all in there too. So they also have worksheets that you can use to send to the kids, and also of course an answer key. So I like to get started with the students with the lessons going through from the Teach Engineering website. And so these are isometric drawings here. So this one is not an isometric drawing, but this one is. So the reason why this one's an isometric drawing is because it's of equal sides. So all the sides pretty much add up to the same degrees as compared to viewed the cube at this specific angle. All right, let's see. And yeah, so these are just and the next part of it is one of my favorite parts is the electronics and coding resources. So for electronics and coding, if you don't know where to begin, I definitely suggest looking at Arduino here. Let's see, Arduino here. So if you click on this, it takes you into some examples and tutorials of the Arduino, which is this website right here. So there's a lot of different tutorials for you guys to get started on. For example, we were going to do this one together on Tinkercad, which is Blink. So this example shows you how an Arduino sees the physical output. So it blinks the onboard LED pretty much. All right, so if you scroll down, I tell my students to scroll down and look at this picture. And on Tinkercad, if you click on circuits under Tinkercad, you can then actually build these components out. So it actually has those pre-built components. So you can pull out an Arduino board like this, and then you can pull out an LED, and then you can also pull out a resistor and actually connect it with the wires together on the Tinkercad website itself. So the students don't actually need to own an Arduino kit. They can actually just build it and simulate it on the Tinkercad website. So once they've built this on their circuit platform, then I tell my students to scroll down and actually take the code here. So the code is actually written out already for them, so they don't need to code it themselves. So the best way for me to teach, like for myself to teach coding, is to really look at different kinds of examples and seeing the patterns between the codes themselves. So for Arduino, of course, we always need a void setup, which is this section of code here. So like this comment says, the setup function runs once when you press reset or power the board. So in this case, for our void setup section of the code, we're telling it that the LED that's built in is an output. It's not an input. So it's gonna output a specific voltage from the board onto the LED or onto the light. And then the loop function, this is where the code is running pretty much over and over again forever. So this piece of code right here is literally saying we're gonna write that LED built in. So the name of the LED, we're gonna write it or designate it as high. So we're turning on the LED. So when we turn on the LED, we're gonna delay it by 1,000 milliseconds. So for Arduino, these are always in milliseconds, not seconds, milliseconds. So the students will see that, all right, the LED is on for 1 second. And then for this specific code, digital write LED built in low, we're telling it that the LED will be off. So it's going to be off, and we're going to delay it by 1 second again, so 1,000 milliseconds. So what this code is pretty much saying is that we're turning on the LED for 1 second, and then we're turning off the LED and keeping it off for 1 second. And then returning back to the beginning of the loop, turning on the LED and then turning off the LED. And so pretty much I tell my students, just copy and paste this code and then paste it into the simulation itself. And then once you click on run simulation on Tinkercad, it will actually run the simulation. So you actually see that the LED will be on and off for 1 second each. So yeah, so that was the one I really wanted to build with you guys, but hopefully you guys can check it out yourselves when you guys create an account on Tinkercad. It's really cool. Yeah, so these are just some good resources to get started with. So this was Arduino was the one that I just showed you guys. This YouTube video will take you to pretty much getting started with Arduino and C++. So C++ is the coding language that Arduino uses, and it's a pretty good start for the students to check out what exactly is C++ and how is it actually structured. And of course, this last resource here that I put, the learn adafruit.com. This is a really cool resource for the students and for yourselves if you want to take a look at different kinds of projects that the students can build. So things like using different kinds of sensors. So like I said, I wanted to show you guys examples of using a photoresistor or a temperature sensor to control whether an LED turns on or off. And also maybe what is it? Looking at turning on a speaker using a push button. So if a push button is pushed, speaker turns on, and then it stays on for like 2 seconds. And so that kind of models how a doorbell works for the students. And so, yeah. Let's see, I know we are going to end early because I wish we could have showed a little bit more on Tinkercad, but it's down for maintenance right now. And so pretty much coming to the very end of it, the students will, for the actual virtual smart home project itself, so I'm going to go back to this one. So the very last unit of actually creating a smart home project. So the first thing that I would really have my students think about is the sensor integration first. I would have them pick, well, not pick, but more so give them 3 sensors, and they have to use those 3 sensors to control different kinds of things around their own smart home on the Tinkercad model. So for example, like we said, you may be using an ultrasonic sensor or a distance sensor where if you wave in front of it, a doorbell will ring. And so they have to actually model that on the circuit itself. Or another one would be using a temperature sensor to determine whether it's hot or cold. And if the temperature sensor senses that it's hot, maybe turning on the ceiling fan, something like that, having a DC motor start running. So that's turning on the fan. Another one would be the photoresistor, which is the light sensor. So having the photoresistor maybe possibly being mounted outside of the home. So if it sees that it's dark, the porch light will turn on in the home. Or if it sees that it's light outside, porch light will be off. So things like that they can model both on the Tinkercad circuit itself and also modeling it on the Tinkercad 3D model. And so that's pretty much the culminating project, is that they would submit 2 pieces of their project, which is first off, the 3D model of their home. And then also the second piece would be the actual circuit simulation of it. So the entire circuit running together with all of their 3 sensors and also the code that they would code to make the circuit run. And then for an extension, if you folks do offer in-person learning, is actually building the physical circuits using Arduino. So the components that you see on the right side, those are the components that I give my students in their Arduino kits. So that's kind of a picture of a kit that I give my students. So every single student has their own kits that they can pretty much start off with. What they see in their kit is like, oh, it's the same thing of what I saw on Tinkercad, so it's kind of familiar. It gives them that familiar sense without it being too overwhelming for them, that they're like, oh my gosh, all these little pieces now, how do I even put it together? It's like, no, you did it once on the Tinkercad simulation. Now you can actually do it yourselves and build it in person. And so I listed the components on here. So if you don't want to pick up the sample Arduino kits on Amazon, I actually purchased all of these components individually, enough for 24 of my engineering students, and actually assembled the kits myself. So those boxes I got from Daiso for $1.50. And then all of these components in the kit, I pretty much got it from Amazon. So all these little electronic components are very, very cheap on Amazon. I was able to assemble these kits together using a STEM grant that I applied and got. So very fortunate to be able to provide the students with these Arduino kits to use. And so, of course, once the students have these physical kits, then they can actually make the circuit and actually test the circuit out. And then if you want to, you can even challenge the students to model the 3D home as what you see here, and then 3D print out different components of the home for them to assemble. So this is what my robotics students actually did, my robotics team students. They did it as part of their STEM research project. So they 3D printed out these wall components, hot glued it to a 12-inch by 12-inch board. So I told them that the board is 12 inches by 12 inches, scale it down so that it still follows pretty much a general floor plan of, say, a small square home. And so I even told them you can even 3D model and print out little furniture if you want. So they 3D printed out, I think, a little toilet here, a sink, a tub. They 3D printed out a bed, a couch, and also a TV. So it's kind of cute. And then, of course, on the right side, this is their final circuit that they built. So like I said, they have their light sensor to control the LED. They have, I think, a push button or ultrasonic sensor to control the speaker for the doorbell. And then lastly, a temperature sensor to control whether the motor or the ceiling fan turns on or off. So a really cool culminating project for the students to do. And if you even want to take it further, you can even teach the students how to solder wire together and actually have them integrate the sensors and mount it inside their 3D printed home. So that's actually like a working house model. So with all of their sensors and everything integrated together into their home. So I think I would say that one will probably be for high school to handle the soldering iron. Or if not, you can do it for your middle schoolers too. Yeah, so I really wish I was able to show you guys the final Tinkercad model and also the final circuit on the Tinkercad website. But I really hope that you guys can check it out for yourselves. The amazing capabilities of Tinkercad. So I really enjoy working with this website, especially during this period of online and also hybrid teaching. I think it definitely allows students to be engaged with 3D modeling and also seeing their projects come to life. I think it's a good alternative to Minecraft, as Minecraft is very blocky in a way, while Tinkercad is more of a little bit of a realistic but still user-friendly type of computer model or CAD model. And also Tinkercad is developed by Autodesk, and Autodesk is they also provide professional CAD software that professional engineers use nowadays. So it would be things like AutoCAD and Revit, other software like that. All right, so we are definitely ending early, but I wanted to thank you guys for the opportunity to listen to my presentation. Thank you to the Augustine Educational Foundation and also, of course, my alum, Sacred Hearts Academy, for providing the opportunity for me to share with you guys kind of the cool things that I've noticed and seen for engineering curriculum that's out there. So again, thank you guys so much. And I guess we'll open it up for questions if there are any questions. And we'll see if the Tinkercad website is working.
No, so I think 4 o'clock. But can you put the link, the Bitly link, on the chat of your slideshow, or is it
Oh,
on
this
there?
one. Yeah, sure. Right. Yeah, so this is a copy of my PowerPoints. Feel free to download it, and then you can use it as reference for you folks, since I know that there are URLs and you won't be able to click on the URLs in the meeting recording once it's uploaded after.
We can open it up and wait a little bit and see if anyone has questions. If you feel more comfortable writing in the chat, we can read your questions on the chat. Um, has there been any challenges for the online students that you have?
Not actually for Tinkercad, not so much. I think a lot of the challenges would be very small challenges like, oh, where's the class code or what's my username? But once they get to that, it's pretty simple.
And you still provide them the kit so they can take it at home and
Yeah.
okay.
So my online students pretty much during winter break, I told them you have to come and pick up your own kit. Otherwise, you won't be able to do this semester's work for class. And then my in-person students have their kits stored in my classroom here. Yeah.
I see. All right. Well, if they would like to get a hold of you, do you want to also just include your email address
Yeah,
on?
sure thing. So my email is listed there, and then I'll also type it in the chat. So it's afung@stlouishawaii.org. If you have any questions about engineering, curriculum related, the specific project, or even robotics, VexIQ robotics. So I coach VexIQ robotics middle school team. And so if you have any questions about that, I'm definitely happy to answer them.
Okay. Do you want to keep it open or do you want me to close it? What would you prefer?
Let's see. I guess if there aren't any more questions, I think we can close this session.
No problem. So let's give a warm mahalo to Adria Fung for everyone's participation for being here. And we know what challenges are in tech. That's why we're in a tech conference. We know what happens. We hope you found this session helpful. And when you get a chance, go on Tinkercad and check it out. We're gonna have please help us complete the evaluation form, which I'll add to the chat right now, and it will be available after the whole conference. So there's the link. Um, and once you do your survey, you'll be entered to win one of $25 Starbucks gift cards. So again, we'd like to say thank you to the Augustine Educational Foundation and Sacred Hearts Academy. Much mahalo for attending this session, and we hope you enjoy the other upcoming sessions. Have a wonderful day. Thank you. Bye.